What we're trying to develop is advanced biofuels, where we're taking non-food based materials and converting that into transportation fuels. We can use any sort of biomass material that's readily available today on a sustainable basis. Things like woody biomass, something you'd find in pulp and paper industry, for instance, forest thinnings, agricultural residues, which are the materials left over after corn is harvested. In the projects we have right now, the specific feedstocks we're looking at are a hardwood material, white oak, which is something you'd burn in your fireplace. We're also looking at corn stover from one of our industrial partners. Now, the first thing we have to do with biomass is grind it up to make it small enough to fit in the reactor, and that's basically taking a log and turning it into chips or sawdust, something like that. Once you get it down to small enough, you can meter it into the reactor, and that reactor's at high temperature. And basically what happens is the woody material liquefies. If you've ever sat around a campfire and you see the smoke entrails going up, what we're trying to do is make smoke and capture that. And once those vapors are released, we run them through a heat exchanger, pull the heat out. Once the vapors then are condensed, we're ending up with what is called a biocrude, which is effectively liquid wood. So we take those biocrude intermediates, if you will, and then do some further upgrading on those to convert them into gasoline and diesel. Well, effectively what we're trying to do is mimic what happens in nature on a geologic time scale. Crude oil, as it's pumped out of the ground, is sat under high temperature and high pressure conditions for hundreds of millions of years, and we're just able to take it out of the ground and process it. We're trying to take biomass material and then convert it to what would be construed as crude oil in fractions of a second at much lower temperatures than you would get at underneath the Earth's surface. We think our process is unique in the catalyst that we use, slightly different than what's being used by other groups around the world. And our reactor concepts are such that we can get those very short residence times, devolatilize the biomass very quickly, produce those vapors, minimize cracking, and then do the condensation very quickly. In the past 3 years, we've really kind of taken this technology from the concept stage all the way to near pilot-ready demonstration. Well, the nice thing about these advanced biofuels technologies is they make fuel molecules that are identical to what you would get from the fuel molecules in petroleum, because these biofuels are literally drop-in replacements that behave exactly like petroleum-derived hydrocarbons. The preliminary economics are positive. One of the attractive features of this technology is that it is cost competitive. The technology is not going to be dependent on any sorts of fuel credits or renewable fuel credits and things like that to make it competitive. So this technology looks like it's something that could produce a commercially viable technology in the near future.